Hello, ladies and gentlemen, to this webinar on the topic of cybersecurity. My name is Georgi Nikolov. I am a researcher at the Research Unit for Cyber Defense at the Royal Military Academy. For many years, I've been working on the project of designing a multi-agent system for advanced persistent threat detection, which I will show today. So let's start with some information first about advanced persistent threats. In the last years, we have seen an exponential rise in the quantity and quality of cyber attacks that have targeted private, public, government, and military networks. One type of attacks that we have observed are the advanced persistent threats. These types of attacks are highly sophisticated, and usually they have been done by state-sponsored threat actors. These types of attacks are very difficult to detect and can stay undetected for extended periods of time in the network, which means that they can do a lot of damage. Usually, the actors who perpetrate such types of attacks have political and economic goals. That's why, more often than not, they try to target political and military infrastructures. The A good thing about advanced persistent threats is that there has been a lot of research into them, and the different phases of the attacks have been outlined in what is called the cyber kill chain. We can see in the image the 7 different steps, starting from reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions on objectives. So now that we know what kind of attacks we are trying to detect, we can talk a bit about the MASFET project. The project itself started in the context of European Defense Agency CATB project, working with a consortium of nations trying to design specifically a detection tool that is proprietary to the military infrastructure. The MASFET framework uses behavior and anomaly-based analysis to detect possible threats. It is highly specialized in the detection of command and control channels through the use of various APT characteristics. And the different APT characteristics that have been analyzed, they produce evidences that are later on aggregated to calculate the final suspiciousness score. Initially, the MASFET framework was designed to use the proxy logs that have been generated by the firewall in any given network, but it is highly customizable and can be extended to use with any type of raw data. And of course, our goal is not to replace any existing tools that are on the market. The goal is that the MASFET framework can be easily integrated in any SIEM or CSOC to use in parallel with existing off-the-shelf products. So the multi-agent system for advanced persistent threat detection is built upon the multi-agent ranking framework. The MARC framework gathers information from various places in any given network. As mentioned earlier, initially we focused on using proxy logs, but it could also be implemented and extended to use, for example, NetFlow, network packages, or endpoint logs coming from Windows, Linux, or Apple machines. All the raw data that has been collected by the tool is fed into the different detection agents. Each detection agent is going to focus on specific APT characteristic, is going to analyze it, and if something suspicious has been detected, is going to produce an evidence. All the evidences at the end are aggregated by our aggregation agents, and a suspiciousness score is generated. All the suspiciousness scores are ordered in a list where the goal is that everything that is very suspicious, very or malicious, everything abnormal is positioned high in the ordered list. That way is more visible for the domain analyst. Again, our goal is to put the domain analyst center stage where we can ease the burden of the analysis for them through the use of the automated detection and then visual analysis for actually understanding what has been detected and analyzed. So this brings a certain dichotomy in the MASFET tool. There is on one side the anomaly detection and on another side the anomaly confirmation. We base ourselves on the principle of situation awareness, which can be applied to the cyber domain. The situation awareness is composed of three phases: perception, comprehension, and projection. The perception phase is used for actually reviewing the information that is generated in any given environment, trying to detect possible patterns or information of importance. This is exactly what the MASFET tool does in the part of anomaly detection. Here, all the raw data is fed into the MASFET tool, analyzed by the different detection agents, and then aggregated to be presented to the analyst, which brings us to the second part, the anomaly confirmation. When the data or the suspiciousness score attributed to different evidences is produced and presented to the analyst, we are helping the anomaly confirmation phase or the comprehension phase of the cyber situation awareness. So the multi-agent cascade on one side serves the perception phase, aims for a high true detection of possible threats, and on the other side, the visualization serves the comprehension phase, aims for higher management of false positive through the use of visual analytics. So to aid the anomaly detection, we have designed so far part of group of different agents, some of them generic and some of them more specific. The generic agents, for example, don't focus so much on the type of connection, the type of data they analyze, and focus more specifically on certain elements of the data, such as the type of connection, the frequency of the connection, the time the connections have been established, for example, the domains and the servers that the client connected to. On the other side, we have specific agents that work with a specific type of raw data. In the case of Squidlocks, we look, for example, for the geolocation of the servers that the clients have connected to, the amount of information and data that has been exchanged between the client and the outside server, and even incorporating some already known indicators of compromise, for example, the Sigma rule set, which combine different already established and analyzed AOCs from APTs, and we try that way we can try to compare what we detect with what was previously known and see if there is some known behavior there. So continuing with the anomaly detection, the multi-agent detection cascade consists of all the different detection agents that have been launched in the MASFET tool. We can see here on the diagram on the left side, we have our data source, and continuing in the cascade, each level symbolizes different detection agents, leading to the right side where we have all our aggregation agent. We can see that in the middle, we can have simple agents that work independently parallel, or we can chain them together and connect them to create more sophisticated analysis, where one agent analyzes a piece of data and their result is further analyzed and filtered. That way, the goal is that each step of the cascade is going to be more precise, leading to the right side where we create the suspiciousness score through the aggregation. So to actually validate and evaluate our results, we have done a lot of tests. How we do the test is actually create our own data set of raw data together with some simulated attacks, where we actually know what type of attacks are. We run our tool and we looked at the ranked list generated by the aggregation. We look at the true detections compared to the false positives. To actually see how they stack together, we create what is called the receiver operand curve, which you can see on the right side. So it's very simple. When we detect a true detection in the ranked list, the value on the y-axis goes up. When we encounter a false positive, the value on the x-axis goes to the right. You can see there that depending on the order the true detection and false positives are in the ranked list, we create something that looks like a staircase. Our ultimate goal is that our curve climbs as fast as possible and reaches as close as possible to one of true detection. Of course, we can't limit the amount of false positives. There's always going to be false positives in any type of behavior or anomaly detection. Well, our goal there is that through the use of visual analytics, we can actually aid the analyst, the human that is going to be responsible of reviewing the evidences generated, in sifting through all the results that are generated, and help them using their own expertise and knowledge and applying them to the visualizations that have been generated by the MASFAT framework to gain insight and more easily say if this is a false positive or a true detection. So again, the anomaly detection is going to push our ROC curve up, and the visual analytics is going to help move the needle to the right, where more evidences can actually be analyzed by the analyst. So again, for our visualization, how we want to help that is to aid the perception phase, where the multi-agent framework is going to receive all the raw data, is going to pass it through the different detection agents, drop the information that is not relevant, and if anything abnormal has been detected, analyze it, do the aggregation with the evidence generated by the different detection agents, and generate the ranked list. This ranked list is used for the comprehension phase. Through the use of visualizations and the human analyst, they can use what has been generated by the tool, use outside data, drop what is not important to them, and gain insight and draw conclusions from the information. With these conclusions and insight that they gather, they can pass through the projection phase, where they can generate alerts if they really think that there's a threat that has been detected in the network, or choose mitigation actions that need to be applied. To help the confirmation, the anomaly confirmation and the comprehension phase, the MASFAT visualization consists of a multitude of different visualizations. We have already seen an example of the detection cascade, which showcases how the different agents are interlinked. We also have the ranked list itself, which shows information about the different evidences generated. There's different ways we can view actually this ranked list, be that a bubble graph or radar chart, and at the end, each of the different detection agents, when we analyze them separately, has the opportunity to generate figures and visualizations to show well how actually the analysis took part. So here are some examples. First, the ranked list. We can see on the left side the ranked list itself, where we have a list of subjects. The subjects here are the connections between server names and the IPs of the client. Each subject has been attributed a score and the time of creation. When the analyst clicks on a specific subject, they see what is shown on the right side, which is a short report about how exactly did the analysis go, what was found, what kind of parameters were used during the analysis, and if any figures have been generated by the detection agents. The analyst also has the possibility to flag this as a false alarm or as a true detection. Further on, there is also a dashboard that can be used. We can see here number one is a time series or a time plot, which shows the amount of evidences that are generated by different agents in a specific time period. It could be a day, a week, or a month. Number two is a donut chart, which shows the quantity of evidences in a different view, which is not temporal as in number one, the number of evidences generated for the different agents. Number three is the general dashboard, the general visualizations. Here we see a bubble graph, which through the use of colors, positioning, and size can draw the attention to the analyst to peculiar information and to something that is maybe more important to analyze. Number four is the list of all the different agents that are running at the moment. Further on, we have visualizations for the different detection agents. Here is an example for the frequency detection agents, which generates the frequency spectrum of the connection. Here, the goal is to see if there is a certain periodicity in the connections established between the client and the server, and because usually that shows some type of abnormal behavior. Usually humans don't use or don't have a periodical behavior when connected to website is more sporadic. So if it's periodic, that means some type of automation has taken place. Further on, we have the fanning out agents, which looks into the specific characteristic of the server. If the server hosts one domain that are attributed multiple IPs or one IP that hosts multiple domains. Usually this is an obfuscation technique used by malicious actors to hide their servers behind a multitude of different IPs or domain names. And last but not least, we have a figure generated by a geo outlier. This is a geolocation detection agent, which creates clusters of all the servers visited by the user. Usually a normal behavior by any given user. They usually visit the same servers all the time, and very rarely will they have outliers, such as, for example, here, the red dot. If we detect an outlier that doesn't belong to any of the typical clusters of servers, that might mean some abnormal activity or something more suspicious that has to be analyzed more in detail. So here ends my presentation. Thank you very much for your attention, and I will gladly answer any questions that you might have.